All right, what I'm going to do is I'm going to walk you through the introduction of the friction lab. So it should look like this on the left-hand side right here. And I'm going to start with a demonstration from the simulation here. And here we have this big block, and I'm going to take this dude, I'm going to push. So you see that it's not going anywhere. And you see as the friction force, as the applied force, the orange one on the right gets bigger, the friction force gets bigger. Bigger and bigger, and I'm pushing. This is like you're pushing something and it doesn't go anywhere. Pushing. And then finally we get it to go. Okay. So the idea here is as we push, it doesn't move right away and friction is changing, which we talked about at the very beginning of the unit. So now this is the friction lab that you're going to be using, the simulation. It's linked at the bottom of this PDF here. And I'm just going to hit begin right here. Now, later on, I'm just going to show you how to use it now, but later on, you're going to change, you'll be assigned a surface type. So you click the words there, and it changes the surface type. And so, maybe wood on lab table. And then you can also change the mass here. Notice it doesn't give you, it kind of does some random numbers on masses. And so you won't get precise, like you won't be able to control it, and that's just by design. So what I'm going to do is I'm going to hit start, and you'll see the force sensor here. So this is the force sensor. You'll see the output of the force sensor here, and then it's going to make a graph for us down here. So you'll watch this number here. So hit start. So it's pulling harder, pull, still not doing anything, pull, and then it goes. Okay. So we saw it here. This is the force. As it pulled more, and then it started going and it dropped down. So what I want you to do is right here, I want you to copy or sketch this graph. So we saw the force of friction go up like this. Oops, let's zoom in here. Oops. Up, and then it came back down, and then it went like this. So a few notes we need to make on this is during this whole time here, this is static friction. So this is when it was not moving. This point here was the maximum static friction. And we can call it F sub Fs if we wanted, or F static friction, force friction static. We don't worry too much about it. There's a few things where this is going to come up. Now this here, this is when it's moving. So this section is the not moving part. And this was the moving. It's going to pull it at a constant velocity. You have to use the information from our forces of motion lab to figure out what that means. So this is moving at constant velocity. And how do we know that? Because that's what they do in the simulation. Okay. So that would mean that this right here is the kinetic friction. Kinetic friction. Oops. Friction. So that's kinetic friction. Maybe we call that like F, force of friction, kinetic, or FK or something like that. Doesn't matter too much. Okay, so you have that graph. What we need to know from this is that there are, the big ideas, there are multiple values for the force of static friction, and it is adapting based on how much you push or pull. But there is one value here for this particular setup of kinetic friction. Okay. So number 3, predict if changing the following variables will increase, decrease, or have no effect on the magnitude of the force acting on the box. I'll let you do that. If the box is more massive, what's going to happen to friction? Will it decrease, stay the same, or increase? If we change the surface type. So if we change from wood on the lab table, oh, it doesn't let you change, you got to hit reset. Also, oh, to read this, you'd have to say, oh, what is friction? The friction force here is about, and then you're going to have to estimate that as best you can. So this would be 0.3, so each of those I think would be 0.2. So 0.38 here, 0.37 or 0.36 would be an appropriate one for this one here. And then you hit reset, and then you can go and you can change. So if we change to glass on glass, would that force be different? And then now there's another way to change the force of friction that doesn't involve changing the surface type, or changing the mass. And what that is, I'm going to see if this works here. So I can't actually see myself on the screen. It's hidden, so I don't know if you can see this or not. So I have a book. Let's see. So I have a book here. And let's say I want to push the book sideways. Very, very easy. Now, if I wanted to push the book this way, and you wanted to stop me, you would maybe push the book in the opposite direction. So now those forces are pushing against each other and the book can't go anywhere. There's another way to stop me, though. You can actually push straight down. So if I'm going to push sideways, and let's say I was pushing straight down and I can't move it. Even though my downward force is not fighting in any way, hopefully you can see, even though my downward force is not fighting in any way my sideways push force, pushing straight down makes it so the book doesn't move. Another thing we can do, and let's see if you can see my wall here. Actually, you can do this. Go get a box or something. I was going to do this in class today, but not on time. So go get a box or something. Now, I can hold up this box just by pushing on the bottom, going against gravity. The other thing I can do, though, I'm lying to you a little bit here, sorry, is I can push the box. Oh, no, I guess I'm not. I can push the box horizontally, perfectly horizontally. Well, if I'm pushing horizontally, how is that counteracting the force of gravity? That's straight down. Or I can take the box, I can put it on the wall. Here we go. Take the box and put it on the wall here and push horizontally. Well, force of gravity is going down. What's holding it up? Well, the answer is friction is holding it up. So let's draw a few FBDs for that. So we're down here, demonstration book on table. So what happened is I had a book on the table. I had a force of gravity here. And then if I wanted to push it one way this way, if I push down, something seemed to change. So as I push down here, this is a downward push force. It's not opposing my horizontal push force, so why does it matter? Well, why does it matter? Because there's another force that's changing. The normal force is going to get a lot bigger here. Fn is getting bigger. And so what we saw is it's actually the force of friction here is opposing me. Even though I'm pushing straight down, the thing when I'm trying to push sideways is the force of friction. Same thing with a book on a wall. So if here's the wall, here's the book, we have force of gravity going down. I'm pushing into the wall. This is my hand pushing into the wall. Well, what's keeping it from falling? Remember, the rule with friction is it's parallel to the surface. Parallel to the surface and opposite direction of sliding. So this book wants to slide down this way. Parallel to the surface, there is a force of friction that's going up this way. And so even though I'm just pushing in, friction is the thing that's counteracting gravity there. So the variable we're going to look at is not actually mass. What changes, you know how you did this prediction right here? Because we can sit there and we can load, more masses and more masses and more masses, but what also is also changing is the force of friction. So mass affects the force of, the normal force. So mass affects the normal force. So the variable is not, that we're going to look at, is not going to be mass. It's actually going to be normal force here. Okay. So part 2, this is what you're going to do tomorrow. I'll give you a quick preview though, is this lab here that I showed you. Whoops, let's change this one. This lab here. It's going to go at a constant velocity. You're going to start the pre-lab by drawing an FBD for constant velocity. We just did big notes on this today with our forces in motion lab. Don't mess this up, because the only way you can solve this is to have this correct. Then you're going to write a net force equation for the x direction, and you're going to write a net force equation for the y direction. And then here, this is kind of a check of what we did in the forces in motion lab, sort of these big ideas. How are you going to figure out the force of friction? Because this here does not measure the force of friction. I'm telling you that, yeah, that's the force of friction. But you need to explain to me why that's okay. So I know I set up here, like, I just kind of glossed over it. I said, this pull force is the force of friction. But why? Because it's not. Because if we were to draw an FBD, this is the pull force, and the force of friction is out in that direction. So my claim is that they're the same, and I need you to explain why they're the same. Then you have the actual lab here. The link is here. It's also in the assignment on Canvas. And each group is going to be assigned a different set of surfaces, two different surfaces to rub together. And then what you're going to do is you're going to vary your mass. You're going to do at least 5 different masses. And then you're going to record the kinetic friction. And then you're going to graph it on pivot, and then you'll be all set. And then the other thing you got to do tomorrow or today, whenever you're watching this, is there's a formative that is will be posted for you. Okay. All right. There you go.